We've been given a right triangle in the unit circle, and I know this is the unit circle because it's a circle and it's centered at the origin, 0, comma 0, and it has a radius of length 1. So this is clearly a radius on this circle, and I can see that the edge of the circle is at 1 on the y-axis. So this is a unit circle, and in this triangle, we want to solve for all of the missing parts of your triangle. We're going to solve for our side lengths, and then we want to solve for our missing angles. So let's start with our missing angle. I know that the angle at the point A is pi over 4 radians. I was given that, and I know that this is a right triangle. I can see my right triangle symbol here. So that angle has a measure of 90 degrees, or in radians, we would think of that as pi over 2 radians. So we want the measure of angle B. So we need to remember that all of the interior angles of a triangle sum to be 180 degrees, or if we're thinking in radians, that's pi radians. So I know that all three angles should sum to be pi radians. So I can just simply take pi radians and I can subtract pi over 4 and pi over 2, the measures of the two angles that I do know, and I can get a value for that, and that should be angle B. So if I find a common denominator here, then I would have 4 pi minus 2 pi, and I see that angle B, or angle ABC, we could call it, is pi over 4 radians. So we found our angle measures, and now we want to look at finding our side lengths. Well, I'm noticing that from point A to point B on the circle is a radius of the circle. So it must also have a length of 1. So now we know the length of the hypotenuse of our of our triangle. So now let's look at our other side values. Well, I can see that both of these angles measure to be pi over 4 radians. And what this is telling me is that those are the two base angles of this triangle. And that makes this an isosceles triangle. And with it being an isosceles, it means that this side and this side are also going to be congruent. So whatever the value, the length of this side is A to C, then C to B will have the same measure. But I'm also noticing that this side here is on the x-axis. And so this would be a distance of x in our x direction. And I'm noticing that this side here would be a distance that would be determined by the y coordinate. So this point here, point B, has coordinates x comma y, which are actually the lengths of the base of this triangle with the way it's situated, and y, the height of this triangle. So let's look and see if we can figure this out. Well, since we know that x and y are actually equal to each other because it's an isosceles, so we can use Pythagorean theorem, and we can find that side squared plus side squared is going to be equal to the hypotenuse squared. If we simplify this, we have 2x squared is equal to 1. If I divide both sides by 2, I get a half. Now I can take the square root of both sides, and I see that x is equal to the square root of 1/2. Now normally we talk about doing plus or minus when we take the square root, but since we are looking for lengths, we know that it's not going to be negative in this instance, because I can see that it's x and y are both positive because we're in quadrant 1. So we just need the positive square root. And so if I simplify this, square root of 1 is 1, and square root of 2 can't really do much with that, but we can rationalize this. We don't normally like to leave square roots in the denominator, so we can rationalize by multiplying by square root of 2 over square root of 2. 1 times square root of 2 is square root of 2, and square root of 2 times square root of 2 is just 2. So we're seeing that both of these lengths are square root of 2 over 2. So actually the coordinates of our point are square root of 2 over 2, comma square root of 2 over 2. Now we want to think about sine, cosine, and tangent. for this angle pi over 4 over here at the vertex A. So if we think about what we know about sine, cosine, and tangent, well, we know that sine of pi over 4, any angle, is always opposite side over our hypotenuse. So for this triangle here, it's the opposite side, which is our y distance, over hypotenuse, which is 1. It's also the y coordinate of our point up here, which is square root of 2 over 2. And then we think about cosine. Well, cosine of pi over 4, or for any angle, we know is the adjacent side over the hypotenuse. Well, for our situation here, our adjacent side is x, and our hypotenuse is 1 because we're in the unit circle. And so we know that it's the x coordinate of that point, which is square root of 2 over 2. And if we think about tangent, well, tangent of pi over 4 is equal to opposite side over the adjacent side. So that would be y over x in our case. And we also am seeing that y is equal to sine of pi over 4, and x is cosine of pi over 4. And so tangent of pi over 4, well, we know that both sine and cosine of pi over 4 we found are square root of 2 over 2. So square root of 2 over 2 divided by itself is going to give us 1 for tangent. So this point up here, also, we can label it as cosine of pi over 4, comma sine of pi over 4.